With me today is John Proctor from Proctor Engineering Group, who's a national expert that can teach us on how to design and size and install these systems so they work better. John, sizing is pretty important. These systems typically are oversized.
You bet, Steve. Air conditioners tend to be really oversized, and the duct systems tend to be way too small.
Since most homes' systems are oversized by a ton or more, what are your tips for sizing systems?
Well, the first thing that they should insist on is to get a load calculation. They have to know that the contractor had sat down, figured out how much window area there was, what kind of windows they are, whether or not they're shaded or not. And from that, they need to calculate what the real size air conditioner is that they need. It's a very standard method of doing that. It's ACA manual J, and getting the right size air conditioner is ACA manual S. And they should insist that every single house that they build, that the AC contractor provides that information to them.
And that has to do with the orientation of the structure, the insulation in the walls, basically everything about the thermal envelope that influences the air conditioning load?
Sure, and especially the windows. That's a really big thing, whether or not high-tech windows or standard windows. We had one system, or one test that was done in Roseville, California, and you had two identical houses, and the only difference between the two was the windows. And the one with the really good windows only took a 2.5-ton air conditioner, whereas the one with the standard windows took a 3.5-ton air conditioner to do exactly the same job.
So that also saves money for the contractor because it costs money to upsize those systems.
That's right. The larger system costs the builder more or the homeowner more, and so you really ought to get the right size. Don't just go by square footage. That's the standard thing to do.
John, attics get upwards over 140 degrees in temperature.
That's right, and that's a really important place to check on the load. The amount of insulation that you have up there, whether or not you have radiant barrier, whether or not you have adequate venting. A lot of attics aren't vented properly.
What are some other penalties for having an oversized system?
Well, there's lots of penalties from an oversized system, besides the fact that it costs more to begin with. Thing is, it costs you every time it runs. It costs you more every time it runs. The short cycles, like starting and stopping your car at every stop sign in a big hurry. You have a big air conditioner, it starts up real fast, cools off the house real fast, and bang, shuts off. Real inefficient.
What is the energy penalty for short cycling?
Well, it's probably on the order of 10–15% perhaps. It depends, of course, on the individual system. But people have this misconception that if you put in a smaller system and it runs a lot, that you're using more energy. That's not true. If you put in a small enough system, it'll run a lot longer, but it draws a lot less amps, a lot less watts as it runs. When you run short cycles, it ends up that it's a lot less efficient. And not only that, if you got any indoor humidity you want to remove, it doesn't do a good job of removing that.
Doesn't run long enough to dehumidify
That's
the air.
right, that's right. Another thing that happens is when you have an oversized air conditioner, you're really hard-pressed to get the right size duct system because you have to move a lot of air through the duct system with a larger air conditioner. And that takes a lot of electrical energy. The watt draw on those fans that move the air through the system can be really high, and the bigger your system is, the more air you have to move, and the harder it is to get the small duct system. Speaking
of ducts, it's really important to size ducts right, and most of them are undersized, right?
Right, so we have air conditioners that's too big, we have ducts that are too small, and again, all you have to do is you have to design it. You have to see what the load is, see how much air you need to deliver to each room to cool the room, and then you design a duct system to do it. And there's a way of doing it. It's called ACA Manual D. It's real straightforward. And every builder and every homeowner ought to insist if they're going to get a new duct system put into their house, then they ought to have a Manual D done, and they ought to get the results from the contractor.
Since most homes built today are production homes, what are your recommendations for working with flex duct?
Well, the most important thing with the flex duct, first of all, is that you design the system to use it. You don't design it like it's metal and then put in flex duct. So you design it right, then you put it in right. So you have nice sweeping bends, you don't crinkle it, you don't shove it down in a wall space to go down to the basement. You don't do any of those kinds of things. When you come to a place where you need a sharp turn, use a metal elbow there instead of just trying to kink the flex duct over. Make sure it's sealed well. Of course, in this whole thing, we aren't getting the right size air conditioner in. We're going to have ducts that don't leak. And at the same time, we're going to have to make sure that we have the right amount of airflow across the coil. We're going to have to make sure we have the right amount of refrigerant charge.
One of the ways to make sure you got proper airflow across the coil, that there are no kinks, crushed areas, and misinstallations that cause that reduction airflow.
Yeah, you really have to make sure that you have a non-restricted duct system. And in the case of a production builder, what you want to do is you want to see how much air needs to flow to each room and the worst case for that room. And then you design your whole duct system to deliver that much air to each of those rooms.
What about return air ducts?
Return air ducts are usually too small, way too small. In fact, the average filter grill that you see out there in the houses in California is good for about a 2.5 ton unit. In most cases, you ought to have probably twice that, just to be safe.
John, climate has a big impact on heating and cooling loads.
Oh, absolutely. If you're in the mountains, for example, you want to make sure that you run through the same calculations on the heating side. Know what the heat loss is of that building so that you can get the right size heater in there to do the job. Same thing with a duct system. It has to be designed as well. Now, if you're on the coast, you may have a lot more moisture, even inside the house. Let's say you've got somebody who has a lot of plants inside the house, has an aquarium, something like that, a lot of moisture. Okay, well there, you're actually going to run the air conditioner a little bit differently to pull out that moisture. And it's going to be different depending upon how hot you are in that particular climate, and of course, how much windows you have.
So John, great information here. Can you kind of summarize what we ought to be looking for in general?
Sure. Well, the first thing is to make sure the thing's sized right. So use ACA Manual J to figure out what size the load is. Use ACA Manual S to figure out what size air conditioner to put in. Use ACA Manual D to decide which size duct system to put in. Make sure it's designed, make sure it's installed right. And then you need to make sure, if you're the builder, you need to make sure the contractor actually does all that and ends up with the right amount of refrigerant in the unit, the right amount of airflow across the coil, and make sure the ducts don't leak. Make sure you have less than 6% duct leakage on these units.
Let's test it with a duct blaster.
That's right. That's right. You need to test it.
John, great information. Thanks.
Thank you very much.